GM, everybody. Welcome to the Solfate podcast, where we talk to founders and builders in the Solana ecosystem. Welcome to the episode.
We had a good one today. Talked to Sean Young, the mastermind behind the Solang compiler that lets you develop smart contracts on Solana using Solidity. It's a pretty sick conversation, right?
Yeah, it was a really great episode. Sean he works at Solana Labs, and he's been working on a Solidity compiler to actually take Solidity code and deploy it on the Solana blockchain as just programs and smart contracts. Super interesting episode. Full disclosure, it is pretty technical. Sean is the compiler engineer behind the project, and so there's a lot of acronyms and words that are pretty uncommon for a lot of people. So we'll have some descriptions and definitions in the show notes to help everybody along. But super interesting episode. Just how Sean and his team are able to take Solidity code and actually make it work on Solana is I think fascinating.
It's pretty awesome. So even if you're not super technical, I think you'll find this conversation fascinating. I certainly did. It's and Sean, this is not a recent thing for Sean. Like it's been years in the making just to get this compiler working for Solana, but he's actually been working on Solidity specific compiler stuff for years even before that, right? So before he got into the Solana ecosystem.
Long time in the making,
so he's got I think it was like 6 years or close to it of experience, like specifically with the Solidity language and trying to create a compiler for it that would take it beyond just EVM, which is super sweet. We also had a great conversation about, what are the differences in developer experience between EVM and Solana? What are the things that a traditional Solidity developer sort of needs to get familiar with Solana in order to port a contract from EVM over to the Solana VM? Really fascinating stuff. I think everyone's going to love this episode, but definitely if you're a developer, if you're pretty technical, I think this is an awesome one for everyone.
Yeah, it's super great. Let's go ahead and just dive right in. Let's go.
But I can't imagine that crypto feels a little bit more exciting than like a massive company like IBM. What got you into crypto in the first place?
Actually, it was one of my friends. I was over just hang and have some drinks, and he had a printout of the EVM yellow paper. He put it in front of me and said, "This is exciting. This is cool." So I read that, and then I discovered that it wasn't just EVM which is exciting. There's much more that's exciting about crypto. From that, I was working at IBM, and then I thought, well, best way to get into crypto is to work for a startup and get to know that. So I left IBM and started working for a small little startup that was doing legal contracts on chain. They had their own blockchain, permission blockchain they were writing. It's based on EVM. And the idea was to have companies manage their contracts on chain and then have different parties do transactions on chain to represent the state of their legal contracts. It was all a really good idea, but convincing companies to do their legal stuff with some startup software turned out to be quite a hard sell. So that didn't really go anywhere, unfortunately. The company Monarchs did move on to NFTs and doing other stuff now. But I was working on their EVM virtual machine and various other bits and bobs of their chain. And I also was writing some code in Solidity as well. And there I kind of realized that there's lots of things you could add to Solidity, but it was kind of hard to do because it was maintained by the Ethereum Foundation, and I didn't want to add any features that didn't exist on Ethereum. I had various issues open and conversations about adding features, and they really weren't going to go anywhere. And of course, that's what they wanted. They want to write a compiler for Ethereum. We wanted to do things like access documents and directly from Solidity, and that was far too big of a feature to add to the sort of C compiler and would never be accepted upstream. So I started
So you're
toying.
saying that your company and you were trying to add features within the Solidity programming language that the Ethereum virtual machine didn't support?
Yes,
Is that what you're saying? And the Ethereum Foundation basically said, we don't want to add that to EVM, so please leave it alone, kind of deal.
Yes, yeah. So
Okay.
their view was, well, if you want to add a feature, you have to go through EIP process and so on. And well, we were like a little side chain, so there's no chance of doing all of that. So I started looking at the compiler and seeing how I could add features. And yeah, I wasn't so impressed by the way it was written. A lot of things were handwritten, like the parser was handwritten, where you normally use a grammar, have a generated parser. I didn't use llvm in any way, shape, or form, so they had their own optimizations. So from that, I thought, well, why not write a new compiler from scratch? And then I first thought, well, that would take me about a year if I did work on that full time. And I started by, on literally a rainy Sunday, writing a proof of concept, something that could parse a tiny bit of Solidity and then compile it, and then run it on, well, I compiled it to WASM because that was easier, and then wrote a WASM virtual machine in the sidechain I was working on. And yeah, it worked. It could only compile a very simple contract that could add two numbers and then return the result, but it did a trick. Yeah, from that I thought, well, there must be. So the company I was working for wasn't interested in investing money in that. So I thought there must be other companies who are kind of in the same situation as this, who want to add features to Solidity, but don't want to be constrained by what the EVM can do right now. And I wrote a few grant proposals. One of the grant proposals I wrote was for the Ethereum Foundation, saying, "Hey, do you want a new compiler written in Rust that uses llvm?" And yeah, that was a hard no, because they said they didn't want competition. In retrospect, I'm not sure why I applied, and I eventually got a grant at Web3 to build a compiler, Solidity compiler for Polkadot, which compiled to WASM, and I worked on that for a year. And from that, I kind of, in that year, I did build out most of the compiler. It was missing sort of features, but for majority of contracts, it would work. And then the grant came to an end, and I didn't know what to do next, so I started looking out for other chains, and I came across Solana, and it's really sort of an accident I came across it. Was just Googling something. I hadn't really paid much attention to it. And then I started to realize that the way they'd done their chain was really interesting and quite novel. I'm in my spare time, I'm a Linux kernel maintainer, and I was really interested in the BPF.
Just casually in your spare time.
Yes, well, I was a maintainer for like I'm a maintainer for a really small subsystem for infrared. It's just kind of like not that many patches come in. So it's quite low traffic. And from that, I learned about BPF, and I thought BPF was like it's really efficient way of doing things. So when I was looking at Solana, I thought, oh, they're using BPF. That's amazing. And then I started learning about the consensus protocol, and I thought, wow, this is so much better. When I was running my test suite on Polkadot, just my test suite, if I run that in parallel, it would, even though I was running a Polkadot node locally, it couldn't cope with all the tests run concurrently. And that's just on my laptop. And I thought, no, I had to remove my parallel option from my watch-out test. Otherwise, it just wouldn't work. So I was looking at Solana, and I thought, well, this is a much better design. This should be able to deal with running things in parallel. And if you want to build a chain which can support thousands of transactions, this is the way to do it. To me, the idea of scaling by parity didn't quite seem the right solution. So I applied for a grant at Solana. I got that, and then halfway through my grant, 5 months or 6 months in or so, I got an email from Anatoly and said, "Hey, do you want to come join Solana Labs?" And by this time, I'd seen how the technology works. I chatted to various people, and I jumped at the opportunity. It was great, and it's been great ever since.
Amazing. That
That's super cool.
Yeah, you clearly have a very technical background that sort of not all developers have, right? There's sort of a range amongst developers of whether you're working on higher level systems or lower level systems or et cetera, and you very clearly have a low level understanding of how things work that I think will be fascinating to a lot of listeners. It at the very least is fascinating to me.
Me too.
I would love to dig in a little bit more and sort of I think maybe there's three things if I had to say what it is that I'd like to talk about, and happy to let the conversation sort of steer itself, but I will call these out. I'd love to just maybe have a quick general chat about compare and contrast between Solana and EVM. Um, that can be somewhat brief, just to sort of set up the background and context for a discussion, more about Solang specifically. But I would love to sort of talk about Solang from two different perspectives. One perspective being if you're already a Solana developer or interested in becoming a Solana developer, what can Solang, do for you? How do you get started there? And then the other sort of perspective, maybe even more important perspective, is if you're a Solidity developer, if you've been developing smart contracts with Solidity for some EVM compatible chain, what does it take to move over to move a contract over to Solana? Why would you do that? What are the advantages there? That sort of thing.
So if you are a Solana developer, then you'd be writing your contracts in Rust, and so Solang simply allows you to write your contracts in Solidity. That's really the difference, just the language. There's you can at the moment you can do everything in Rust, and we're working towards feature parity with Rust. There's a few areas where we're still improving on.
How far off would you say feature parity between Solidity and Rust for Solana development is?
Yeah, so I've actually this week been working on a long-term plan, and so the long-term vision is you can write contracts on Solana in Rust or in Solidity, whatever sort of, you would like, and we want developers to have a good experience writing Solidity, and be able to do everything you can do in Solidity, which you can do in Rust. Rust comes with a whole bunch of great tools, and Solidity, Solang. We have the compiler right now, but we need more. The Anchor tooling needs a bit of polish. There are various features which you can't do in Solidity yet, or you can do, but there are the manuals. If you want to call another contract, if you have an IDL, then you can make a call across to another contract from based on how the IDL describes the other contract. But in Solidity, you don't have a feature like option, for example. So an option is something which is present and then it has a value, or it's not present, and that simply doesn't exist in Solidity language. So we're going to have to add that to the language.
Why do you think that is that the Solidity language doesn't have that sort of basic basic type, right? I personally, I spent a couple of years doing some contract development on EVM chains in Solidity, and it in many ways is a great language, and in many ways it's somewhat primitive. And I'm curious from your perspective, why do you think that is? Why do you think it's missing those sorts of features?
Yes, why is it? I think the language has sort of grown organically, and it just never really got added. I
Got
think
it.
um, it's a language which is vaguely based on C++, JavaScript maybe, but its features are very limited. So one of the things I was quite keen on adding myself was if you're writing a contract in Solidity and you're trying to debug it, then often just if you're writing in C or in Rust or so, you just do a println just to find out what the value is at a particular point. And in Solidity, you'd have to emit an event or so to get some information out of it. But on Solana, there's a program log, which you don't have on EVM. So with Solang, you can just do print, and then you can have a string and some variables, and you can instantly see what the values are at that point. To me, it seems like that's kind of a feature you want in any language is a basic print. Why it doesn't exist in Solidity, I don't know, to be honest.
Yes, especially for debugging, like being able to print out arbitrary data is so useful for every developer. That's like 90% of developers. That's like 80% of their debugging experience is like, here's a value, print this value. Like, is it what I thought it would be?
Yeah, has the Solidity language? Do you feel like the Solidity language has just kind of taken a back seat to other advances and things that Ethereum Foundation and the Ethereum community want to work on? Is it just like it's good enough for what we are trying to work on here?
I think there is partly there is a it's good enough, but I also think there's there's kind of an aversion. If Ethereum community there's a real aversion to change. That the EVM is a deterministic distributed virtual machine, so it's not a. It has a lot of limitations that you wouldn't have in if you're just developing for your local machine. So there are reasons why a lot of things aren't present, like file access or so, because that doesn't make sense on a blockchain. So it is simply a limited environment, but still, yeah, you want features like options and print. I'd say.
I mean, a lot of languages don't have the option. Like JavaScript has been around for JavaScript and ECMAScript have been around for a long time now, and they still don't even have an option. They have the primitive values that you can build an option yourself, but it's still not really there built into the language. And like, I don't think PHP has an option either. Um,
Yes,
JavaScript is
although
also like a
all languages
dynamic.
should have an option.
Yeah.
It is a phenomenal data type. Phenomenal.
Well, I was just say like JavaScript is like an untyped dynamic language, so I don't know that it's not that the comparison is invalid, right? But Solidity is sort of this statically typed it's language where I would expect it to have features similar to other more modern statically typed languages.
yes. By writing our own compiler, we're kind of free to expand the language as we want. So
Yeah.
that's another thing.
So that's one of the questions I kind of have. Since very few people like have a strong understanding of how compiler engineering works and what all that encompasses. So I want to kind of go down this path a little bit of what does it mean to like be writing a compiler? And you said you made some comments about adding some features to Solidity as a language. Is this does the Solang project now need to maintain a new version of Solidity as a language, like a forked version, and then handle versioning as new features get added, or is it purely handled within the compiler at build time or at compile time rather, where it's all of these features that the Solang compiler accepts for the Solidity language, the compiler handles everything, and you don't have to really touch. You don't have to like modify Solidity as a base language.
It's all built into the compiler, so we have to change the compiler in order to add new features. So you asked how a compiler is built, and well, when I studied compilers at university, I thoroughly enjoyed it, and I knew that was the direction I wanted to go into. So first you pass the source code, and then you get what's called a parse tree, and it really is a tree where you get a list of all the functions in the file, and each function you have the parameters and the return values, and then a list of statements inside, and the statements can be nested. So if you have an if statement, then inside an if statement you may have a then or an else. And
this would be similar to like the Rust abstract syntax tree that you use when writing macros.
Yes, absolutely, very very similar. Yes, that's exactly the same thing. So you have so you first get the parse tree, and then you need to kind of validate that this is valid Solidity. So all the variable names need to be resolved. So you have all your whenever you use a variable, you need to make sure that it exists and it refers to the right thing. So you can create a symbol table for that, and then you have a fully resolved tree. And now once you have that, and there were no errors in the code, then you go to next stages, and the next stages you convert to what's called a control flow graph, where you use the code down into instructions of do this, do that, and so this becomes more and more low level at each stage. So this is setting variable names, calling Solana system functions, also returning, exiting if there's an error. So when you type some Solidity code or some Rust code, then when it's compiled, it may consist of a lot more instructions. But once we have that, we can pass it on to llvm, and llvm is kind of feels like quite a magical project. You give it some format of code, and then it does all these great optimizations, and then produces a binary for you. So a lot of the really tricky stuff is done for us, which is really great because we can focus on the front end, on the parsing and the design of the language, and giving sort of useful error messages when source code isn't quite right. All the magic happens in llvm, really.
At what point does it start being supported by the Solana virtual machine? So is anything llvm compatible with Solana, or like at what point are you tying in to make the Solidity that you've parsed compatible with Solana's architecture?
So we parse it, we create this control flow graph, and then we convert it to what's called llvm IR, and then the llvm libraries were converted to SBF or BPF instructions, and only then is it something which can be run on the virtual machine.
Got it. So it's the BPF instructions that Solana supports. So basically, any language, if you can get it to, llvm and then to BPF, you could theoretically, deploy that thing on Solana.
Yes, absolutely. So there's another project going on in Solana where they're trying to compile the Move programming language to Solana, and that has pretty much the same approach. So you parse Move, and you create llvm IR, and then you pass to llvm to create the BPF instructions for you. And yeah, that's it. The llvm libraries have really changed the landscape of compilers. there are so many more compilers around because the llvm toolkit allows you to
do so much.
do so much. Absolutely.
What
So then with for language expansion, I'm going to jump in, James. For
Please do.
language expansion for other languages at being supported within the Solana ecosystem, because like you said, there's someone working on Move, there's another team that's working on a Zig compiler, like you're working on Solidity, and from my understanding from a separate conversation I've had with a different compiler engineer, um, anything that basically like James is saying is if the code can be compiled down to llvm compatible code, that can then basically be pipelined into like the default, we'll call it the native Solana compiler, for lack of better phrasing. It takes that llvm code, converts it to bpf or sbef code, and then that is what the Solana virtual machine actually can understand and interpret. So as long as like everything that can compile down to llvm can then just go through the normal, effectively the way that Rust gets compiled into Solana code on the Solana blockchain. Is that correct? Is that the understanding?
Yeah, absolutely. So JavaScript or TypeScript is a little bit hard to do that because it's dynamically typed, and llvm IR is statically typed.
Mm-hmm.
But there is something called assembly script, which is like TypeScript but with static types. And one of the things,
Haven't heard of this before.
Yeah, one of the things that I've been looking forward to, but life's too short, you can only do one thing at a time, is applying assembly script to Solana. So I'm hoping someone will work on that one day.
Is
Interesting.
So
Okay.
I'm curious if a language already uses, if a language's existing compiler already uses LLVM, then the starting point for making this language compatible with Solana is much different than say what you're doing with Solidity, where the sort of the you're just creating an entirely separate compiler rather than branching off at a certain stage from the existing compiler,
Yes,
right?
yes. So
So,
the sorry, yeah.
so how well, so there's kind of a follow on there, which is it seems that what Solang is doing with Solidity is, is maybe somewhat tricky from like a versioning and maintainability standpoint, where you basically just have two entirely separate branches of the Solidity language, right? There's sort of the official Solidity that's maintained by the Ethereum Foundation, and then there's the Solang compiler, which is an entirely separate branch. What's the plan for keeping those in sync, compatible with each other, or are we not too concerned about that?
I
Well,
mean, Sean did say that Solidity as a language doesn't really get new features added to it.
That's kind of my
That
point
makes
here, right?
maintainability a little bit easier.
yeah, that's absolutely right. Yes, the fact that it moves slowly, it's been a huge advantage to us. The Solidity Ethereum Solidity compiler has a very large test suite, and we run the same test suite on our compiler. And yeah, there are still some issues, so we're working on those, but they're all sort of strange edge cases. That once you run those test suites and you start getting bug reports, you discover that there's all sorts of weird edge cases. Like if you have a bytes type, you can initialize it with the value just with a literal 0. You don't need a hex string or so. So any type can be initialized or can be set to the value 0, including strings. But if you do 1, then it's not allowed. There's some strange edge cases. Having said all that, there are we're not entirely compatible with Solc, the Ethereum compiler, because Solana is a very different blockchain. It has a very different virtual machine, which is designed from the ground up about for parallelism and for speed. So there are differences we had to make in the language.
Yeah. So the goal wouldn't be for Solang to be compatible with Solidity's compiler, but we would want the other way around, right? We would want everything that Solidity currently has to be supported with Solang. Is that
Yes,
right?
yeah. I mean, we do our best to make sure everything that we can do that can work on Solana will work on Solana.
Yeah, and you just run their test suite, and if something ever changes that you need to, look into and modify, that's simple enough that you're not too worried about it.
Yes, so
And being these two separate tracks.
Yes, we run it in our CI, and I keep track of the going ons in their code base, and whenever they do a release, I make sure that we're up to date.
How often do they do a release? How often does that happen for Solidity?
It's not done often. It's sort of every 4 to 6 months or so they do a release.
Are those pretty minor typically?
Well, they're minor in the sense of that there's usually not many additions to the language. They're doing a lot of one of the things that costs them a lot of time is that they've implemented their optimizations themselves, so they don't use llvm, and compiler theory is a subject which is hugely complex, and papers are still being written about this every week really. I go to the LLVM conferences, and there's always something interesting being discussed. To write LLVM from scratch, it seems like that's not a good idea. It's
Sounds time consuming.
yeah, so that sort of really kind of slows them down. Having said that, LLVM can't compile to the EVM virtual machine, so they kind of have to either add their own compiler or add an EVM backend to LLVM.
Would, if you were starting, if you were sort of heading up the Solidity initiative for Ethereum Foundation, is that the approach you would take, making LLVM compatible with EVM rather than rewriting LLVM? Or do you think, given the trade-offs, they've done what you would do?
Well, they're one of the paths I've sometimes wondered about is adding an EVM target to Solang, and kind of compete head to head with Salt C.
That's interesting.
That's ew, yeah.
Yeah, because it's something that's sort of in the back of my mind, and something I'd really like to work on. I just don't have the time for that. So I do wonder, how would I go about that? And adding support to LLVM would definitely be the way to do that. There's there was a project a few years ago. I forget who wrote it, but it's somewhere on GitHub, where someone started on an EVM backend to LLVM, and I spoke to the DD for a few times. I met him at a conference, and he just lost funding, and the project sort of never really went anywhere, which is a real shame, because if someone wrote an EVM backend to LLVM, then it would be very easy to add EVM support to Solang, and then you compete head to head with Salt C, which would be very interesting. Having said that, I think BPF is a much nicer instruction set. I think it's much nicer design, and you would never get the same speed with an EVM chain as you could get with Solana. So the ecosystem is very much EVM centric. But the way I see it, I think the future for sort of massively parallel transaction machines is not in EVM, unless you start doing roll-ups or things like that.
Yeah. Are you? I mean, this is maybe a bit of a divergence in topic from Solang specifically, but just given your background working with sort of an EVM based chain for so many years, and then now, and then also working with Polkadot, and then now Solana, I I feel like I would be missing an opportunity if I didn't sort of ask you what you think matters most in blockchain technology, and what you think is going to, what you think the future of blockchain technology really looks like.
Well, I'm very much focused on the virtual machine and the compiler part, and that's very much been my focus. And I kind of feel like I can only speak about those parts. Having said that, I think as virtual machines go, Solana has a very good design, and there's a version 2 coming out, being worked on, the program runtime v2, and that has actually some very good optimizations, which I actually feel quite novel, and I hadn't really thought about them until someone started working on them. So normally when one contract calls another contract, you have to create a new VM, and and then you have to switch to the new contract and new VM. And then once that contract is done, that virtual machine gets torn down and gets cleaned up, and then the result gets returned to the calling contract. So with program runtime v2, the whole of the Solana runtime is essentially one VM. So one contract can call another, and it's all in the same VM. So there's no teardown, setup, and so on.
Yeah.
And it's
sounds significantly more performant.
Yeah, it's significantly more performant. Yes. So as far as I can see, I'm very excited about this, and this is, as far as I know, this is the best you can do with a virtual machine. So Solana work on the llvm backend for SBF, that makes it possible to write all these languages. So this is what I'm excited about.
That kind of toys at another question I have of not only are you trying to maintain more or less feature parity with the Solidity language, but you're also trying to maintain some amount of parity in whatever that means with Solana, period, whether that's the current runtime implementation or runtime v2. How does Solang get affected by the changes of the underlying like blockchain of Solana in the runtime? Because like as changes go and get implemented and validators actually roll out those updated versions of the validator client, naturally things change. How do those changes actually affect Solang and how the Solidity code gets compiled down? Is it just as simple and as straightforward as some changes will be more or less not affected and other changes, more complex ones, that the Solang compiler will have to change to like support those new features or the new changes, whatever those are, within Solana as a blockchain?
A lot of the features on Solana don't really affect the program runtime. Most of the features are sort of and optimizations are outside of the virtual machine. So luckily, we're mostly isolated. It's more features like SBL token 22 or so, or 2022, and then we have to make sure that you can use a new token program from Solidity, So the program runtime v2 is a big feature, and that will definitely affect us. I am both excited about it and worried about the amount of time it's going to cost to implement it.
Sure, fair enough.
Yes, but on the whole, the amount of change we need to do to Solana changing has been quite limited, and it's been quite manageable.
That sounds like
Cool.
good architecture then, right?
Yeah.
If they're able to make
Weird.
big changes without it causing you too much headache.
Yes. Also, for the changes that have been, Solana maintains the llvm backend for BPF and SBF. So I just update the compiler toolkit, and everything works again.
Nice. Nice.
I love it.
What are the modifications that you've had to make to Solidity in order to? So, yeah, maybe I'm gonna roll back that question real quick. From the perspective of a Solidity developer, right? So the developer experience. I'm on Solidity. I would like to make a contract work on Solana using Solang. What are the additional features that I'm not currently aware of as a traditional Solidity developer that are added that I sort of have to familiarize myself with in order to get this contract up and running on Solana?
Yeah, so there are a few things which are different. Writing in the Solidity language doesn't isolate you from the fact that Solana is just works very differently. One big difference is when you Solana is designed to be a parallel virtual machine, so many contracts can execute in the validator at the same time. And the way this works is that the execution engine knows which contracts are going to be used in a transaction. So if two transactions happen at the same time and they don't touch the same contracts, they can run in parallel. So that makes it much faster. This means that you need to provide the accounts which are needed for a transaction. So in the client code, you need to pass in a list of the accounts which are going to be required for the transaction. And when one contract calls another, there's an accounts call argument where you specify the list of accounts which you're going to need. So there's that. There's things which are easier on Solana. So on EVM or Ethereum, if you want to upgrade the contract, then you usually have like a proxy contract, which then gets redirected to a new version when the contract gets upgraded. And that's not really necessary on Solana because you can upgrade program code. That's just a feature of Solana itself. So you can just update it with some client with the command line tools. So the whole upgrade path, which uses the proxy contracts, is unnecessary. Also, usually uses a feature called delegate call, which is not a feature which works on Solana. So all that code will kind of have to be removed and replaced with simpler code, but it's still a change. There's if you want to interact with tokens, then on Solana you can use SPL token, and SPL token isn't very different from ERC20. So code will have to be updated to use SPL token calls rather than ERC20 calls. They're very similar, but because they're on Solana, they need lists of accounts, so those will have to be provided.
Got it. So it's, I mean, obviously, and this I think is sort of self-evident to anyone who's done Solana development, but maybe isn't self-evident to someone coming from EVM. You, even though you're using Solidity, you're still writing code. You still have to write code within the Solana programming model. Is basically what you're describing, which means you, in order to reap the benefits of Solana's architecture that allows for transaction parallelization, you have to pass in a list of the accounts that you're going to interact with and the contracts that are going to be called, and that is very different. That is a very different mental model than what exists on EVM. EVM, your EVM model is a lot more just like, honestly, writing a contract feels a lot like just writing a class, right? I write a class, I do my stuff inside that class. It's fairly contained. I don't worry about what happens outside of this. All good. Whereas in order to reap the benefits of Solana performance, we have to put a little bit more thought into what actually is happening outside of this contract, what needs to get passed into it, what's going to be used in order for validators to run those transactions in parallel. So I guess what I'd say to any listeners who maybe are traditional Solidity developers who are interested in working with Solana, you'll still have to learn the Solana programming model.
Mm-hmm.
You can do it with a language you're familiar with, which is awesome, but you still need to understand a little bit about how this machine works.
Absolutely. And on if you're writing Solidity for the EVM, then you're also sort of explicitly or implicitly aware of how EVM works.
Yes.
So you kind of have to kind of switch that out and replace that with understanding of how Solana works.
I
Probably
feel like
implicitly aware is more likely.
yeah. Well, honestly, that is a pro and con, I think, of EVM. Is like for simple contracts, it is, I think, quite easy to get up and running for someone who's not done smart contract development before.
Mm-hmm.
It feels fairly intuitive, and you don't really have to worry about what's happening. It just kind of works. But once you get past even the most basic of contracts, uh, you start to run into issues with optimization and not sort of understanding security risks of certain things that you're doing. A lot of the you have to explicitly know what's happening with the Solana programming model. While it is an upfront hurdle, it is then much easier for you to sort of grow from there and do more complex things without running into issues because you already understand what's happening under the hood. I found that while with Solidity EVM, it was very easy for me to write my first couple of smart contracts. The hurdle from sort of beginner to intermediate was then quite large, whereas that hurdle on Solana is kind of front loaded a little bit.
Yeah, I think that's a really good way of looking at it.
Yeah, I totally
I don't
agree.
know, Sean, if that matches sort of your experience, but that was certainly my experience writing Solidity contracts for Ethereum and Polygon, and then learning Solana and being like, oh, this is very, very different. I can't just one-to-one map my mental model of Ethereum over to Solana.
Yes, I agree. It also took me some time to understand the Solana VM. I'm glad I did because it's it's a unique but also a very well designed way of doing things, and it's I think it's worth knowing about.
Do you see a future where some of the explicit passing in of accounts and that sort of thing is ever abstracted away a bit more from the developer, um, somewhat like what happens now with it within Anchor, right? Anchor currently has features that can allow for accounts to be resolved for you, so that you don't, if there's 15 accounts required for an instruction, maybe you only have to explicitly provide 3, and Anchor sort of resolves the rest because they can be they're more or less implied. Do you see a system where that exists, but rather than it being an Anchor thing, it's actually embedded into um, the Solana programming model?
Yeah, the runtime is designed to be for speed, so things which can be kind of front loaded and have it makes sense for the runtime to not have to do these things because that would affect the execution speed. Having said that, I have wondered about whether you can kind of you could sort of what's the word optimistically execute where you just go you start executing a transaction, and if you need another account, then it just gets added into the transaction, and then you don't need to specify them up ahead. The only problem then is a traditional database deadlock, where so say you have a transaction and you don't specify the accounts, it just uses whatever accounts it needs. So then it first say you need account A, and then later you decide, oh, I need account B. So you've locked account A, and now you're going on to account B. Now, if another transaction was happening at the same time that had locked B already, but I wanted to lock A, then we have a traditional deadlock, and we'd have to roll back the transaction and retry. Not only that, the execution engine would have to detect these deadlocks, and there's great ways of doing this, so it is possible. I hope one day we can implement this, because it is a pain point having to specify the transactions, and it would improve the developer experience.
I think though,
there's
for
always
that
a
specific
balance.
thing though, like it runs into the fact of if the runtime doesn't know ahead of time which accounts that it needs to write lock, because reads are fine, it can read everything fine without problems, but for write locks, if it write locks one account and then starts doing some computation, you're utilizing compute on the validator, but then the validator doesn't yet know if that transaction is going to be like successful, because maybe it gets 3 steps in of processing whatever code it's trying to execute, and then it really realizes, oh wait, I need this other account that wasn't passed into me, I need to write like that one. That it's like, okay, well now I have to roll back all that processing that I've already done and then redo it. So it just seems like that model would just result in additional compute and for no gain.
Yeah. I don't know. I mostly ask the question because I'm always curious about seeing if we can have the best of both worlds, right? I certainly can see the logic there, Nick. But I also don't want to assume that because I can't find a way to make it work, nobody can. So, right? There are much smarter people than myself out there, like Sean, who are building great things that I then can sort of use to build stuff, right? Well, look, we can. I think this is probably a great place to wrap up. Sean, I have so appreciated digging in to compilers a little bit with you. I am not that low level of a developer. I do my best to understand from afar. I always I do quite a bit of developer education, and what I always try to tell students is, you don't necessarily need to know something five levels deeper than where you're going to be developing, but I do think you need to know how things work 2 levels deeper, right? So if you're just sort of doing a UI layer of something, you should understand how things work 2 levels below that, because inevitably you're going to run into hiccups where you have to kind of dip down into something that you would maybe otherwise be less familiar with, and you'll be far more effective if you can understand it. So even for the developers out there who are not working on compilers, I think this sort of conversation and sort of discussion around, how can you make a language compatible with the Solana EVM, or sorry, the Solana VM, would, I think it's greatly beneficial even for those who aren't working maybe directly with the Solana runtime and that sort of thing. So thank you so much for sharing your knowledge with us.
Yeah, thanks a lot, Sean.
Well, thank you very much for having me. It's it's been great talking about something we've been working on for many years now, and I look forward to hearing what people think and trying it out and seeing how they get on. It's
awesome.
Yeah, I've been working on a few years, and although it is nice working compilers, what you really want is people to use your software. So, but now we're getting to the point where this is now happening. So it's a great time, really. We're looking forward to it.
Yeah, and naturally we'll have a bunch of links in the show notes of like some getting started guides on Solang itself and the Solang documentation, as well as the repo, because we love open source software. So
awesome.
if you're listening and you're interested in Solidity as a programming language, or how to use Solidity on Solana, then definitely check those out.
Great. Well, thanks again, Sean. To the listeners, we'll see you all next week.
Thank you very much.
Bye bye.
Thank you.